write please on top of your paper prime factorization, which is also known as, aka, division by primes. Which is also known as factor trees. Or I like to call it the tree thing. And in order to do this, maybe they didn't tell us here. In order to do this, I believe that we've talked about composite prime numbers, correct? A composite number is, Delaney Guiney? You know, right off the top of your head? Who remembers what a composite, what's the difference between a prime number and a composite number? Elijah?
Prime number only has two factors and composite has more than two.
Okay, composite numbers are made up of other numbers besides just one in itself. Prime numbers are made up just of one times themselves. And what you are looking to do here is this, okay? If you have the number 6, the number 6 is a composite number. And when you are asked to either do this, usually they ask you to prime factorize that. And what they're asking you to do is to break the number 6 down so that it is the product of whatever prime numbers will make that number. In other words, let me give you the example. 6 prime factorized would be 2 times 3. Because 2 and 3 are both prime numbers, you multiply 2 and 3 together, you get 6. 8 children, okay, you could write 2 times 4, but that's not correct because 4 is not a prime number. 2 is a prime number, 4 is still composite, so you'd have to break 4 down and make it 2 times 2. 8 is the product you get when you multiply these 3 prime numbers together. 2 times 2 is 4 times 2 is 8. Now, rather than trying to do it mentally, we have 2 different ways to do it. We can do it by using factor trees, and that would be this. If I was doing 8 using a factor tree, you make 8 the top of the tree, you break some branches off, and you say, okay, what times what gives me 8? Well, that's where my 4 times 2 came from. Once you get a prime number, go ahead and circle it so that you know you can't break it down anymore. 4 can be broken down into 2 times 2. Those are both prime numbers, so you can circle and stop with that. 8 is the product of 2 times 2 times 2. 8 equals 2 times 2 times 2. And when you write down its prime factorization, please write it, group the numbers together from smallest to biggest. Another example of that would be this. Here's 12. What times what gives you 12? And you have a couple different options. You'll get the right answer in the end no matter which way you do. Brianna says 6 times 2. Now, are either one of those prime numbers? 2 is, so I can stop with 2. But 6 can be broken down into, what times what is 6? Drew?
2 times 3.
2 times 3. Are those both prime? Absolutely. So the answer is 2 times 2 times 3. That is the prime factorization of 12. And please don't go, some people get kind of confused and then they start doing, well, 2 can be broken down into 1 times 2. Yeah, but you could just keep going on with that for absolutely ever. Because all of these could be times 1. 1 we're not worried about because 1 makes something a prime number. Let's do a harder one. Well, let's say 10, or no, let's say 100. And again, it doesn't matter what number you start with, you'll get the same answer in the end. You could take 25 times 4, you could do 50 times 2, you could do 10 times 10, either way. Riley says let's do
10 times 10.
Okay, 10 times 10. Either one of those prime? No, you can break those down. What does 10 equal? What times what gives you 10, Isabel? 5 times 2. Those are both prime, so you can stop there. 10 is 2 times 5 again, and those are both prime, so you can stop with those. So when you write down the answer, because this is how I'll read it when I say the answers, do it smallest to biggest and write them all down. 2 times 2 times 5 times 5 is the prime factorization. Okay. Now, there is another way, if you remember back to this little screen here, we talked about prime factorization, and the way we did this was with factor trees. These are factor trees because they look like little trees. Another way to prime factorize is to use this division by primes. And that would work like this. It works better when you have bigger numbers like this. Let's say you've got 144 and you don't really know what times what gives you 144. What you can do is this. It's called division by primes because you're going to divide 144 by a prime number. And usually the prime number you want to use, if it's an even number, is 2 because it's easy to cut numbers in half. So I write my prime number here, which is 2. What is half of 44? 72. Can I divide 72 by a prime number? Sure. It can be cut in half again, correct? What's half of 72? Teeth, half 72? Yeah, 36. Good call. Can 36 be cut in half? Yep. Every even number can be cut in half. Half of 36 is 18. Can 18 be cut in half? Yep, it's 9. 9 can't be cut in half, but it can be divided by a prime number. What prime number can you divide into 9, Jaden? 3. And 9 divided by 3 is 3. Once you get a prime number for your answer, you can stop because nothing goes into 3. All of these things outside of the box are your prime numbers that get multiplied together to get you. So I've got 1, 2, 3, 4, 4 2s and 2 3s. This is the prime factorization of 144. If you were to multiply all that together again, you would get 144. You know, another example may be 50. What prime number goes into 50? Again, if it's even, I always try to cut it in half. Half of 50 is 25. That's not even, but what number goes into 25? 5. 5 times 5. And once you get a prime number on top, these are your prime numbers that multiply together to give you that. 2 times 5 times 5. We do a lot with this later on, so it's kind of a good thing for you to get used to doing. Let me give you one for you to try. And the book will usually tell you. It'll tell you to use a factor tree, or it'll tell you to use division by primes. Right now, right where you're at, use a factor tree to prime factorize 60. Take 60, use the little tree thing, not division by prime, but do the tree thing. Break it down and see if you can't get what times what times what times what will give you 60. They all have to be prime numbers. Never will you get 4 in your answer, because 4 is not a prime number. Never will you get 6 or 8. None of those can you have in your answer. So you have to make sure that it is all prime numbers. Second here. Luke says, what'd you get, Luke?
2 times 2 times 3 times 5.
2 times 2 times 3 times 5. I don't know if that's right, but I'll write it down and then we'll check. 60, however you want to split it up, I would go 6 times 10. Neither one of those is prime, so 6 can be split into 2 times 3. Those are both prime, so I'm going to stop with those. 10 is 2 times 5. Again, both prime, so I stop with that. So I have 2 times 2 times 3 times 5. This is the prime factorization of 60. Emma?
Is it okay if we do it a different way, like we do 3
Absolutely.
times 2?
Yep, you will still get this. If you do it right, you'll still get this for your answer. It doesn't matter how you slice it. 4 times 15, 2 times 30, 12 times 5. Any of those will still get you that sort of thing. Now, one more, doing it as a division by primes. Take 36 and divide it by primes. In other words, put the little division box, think of a prime number that goes into 36, it's even, so you should be able to figure that one out pretty easily. And see if you can figure out how to get the product of primes going that way. Brooklyn Peterson says,
The answer is 2 times 3 times 6.
did you say times 6?
Yep.
6 is not allowed because 6 is not a prime number. So if you got 6 at the top of your division by primes, you need to just take it into something else there. Elaine?
2 times 2 times 3 times 3.
2 times 2 times 3 times 3, let's see. I'm guessing you cut this in half. Half of 36 is 18. 18 being cut half again, you get 9. What number goes in 9? 3. And 3 times 3 is 9. So 2 times 2 times 3 times 3. That there. Brooklyn, you see where you went wrong?
Yep.
Any questions, problems, concerns, frustrations, anxieties, worries?